All right, thank you so much for joining us today. So in this video, we are going to take the method 2, where the discriminant aspect is equal to 0. So we said anytime the discriminant is equal to 0, then the differential equation has what? Equal root. That is, m1 is the same as m2. And we are going to have our general solution to be in this form, right? So let's take some example to practice. So as I said in the previous video, always whenever we are solving homogeneous second order differential equation, we start by saying that let y equals to e to the power mx. And this one will help us to find y prime, which is mx, and y prime prime m squared e mx. So as soon as we get this information, we plug them inside the differential equation. So we are going to have m squared e to the power mx minus 4 mx plus 4 e to the power mx. So what do we need to do? This is repeating itself, so we can factor it out. So e to the power mx out, it will be left with m squared minus 4m plus 4 is equal to 0, right? So the same thing, now we set this not to be equal to 0, and we are going to pick m squared minus 4m plus 4 to be the characteristics polynomial. And for us to get the characteristics root, then we need to set m squared minus 4m plus 4 to be equal to 0. Now, this is the characteristics equation. Now, this one, if you can just solve it using, simplification or factorization, you can just go ahead, or you can use the quadratic formula to solve. So I can write this one as m squared minus 2m plus 4 is equal to 0. So this is, I'll take the first one with the red and I'll take the second one with the blue. So I'm going to have factor m out, and it will be left with m minus 2. One with the blue, when I factor minus 2 out, m minus 2 also. So when I factor m minus 2 out, it will be left with m minus 2 is equal to 0. And then m will be equal to m minus 2 will be equal to 0. This implies that m is equal to 2. Another m minus 2 is equal to 0. This implies that m is equal to 2. Okay, so since we are even using the idea that this is equal to 0, let me use the quadratic function also to see if that place is going to be 0. So let's see, a is equal to 1, b is equal to minus 4, c is equal to 4. So if I'm using the quadratic formula, this is going to be minus 4 plus or minus square root of minus 4 squared minus 4 times 1 times 4, all divided by 2 times 1. So if we have forgotten the quadratic formula is minus b plus or minus square root of b squared minus 4ac divided by 2a. So that was what I was just doing. So let's simplify. This is going to be giving us 4 plus or minus square root of minus 4 squared is 16 minus 16 divided by 2. And we can see that 16 minus 16 is going to give us 0. So it means that we are going to have something like 4 plus or minus 0 divided by 2. So when I pick m1, which is equal to 4 plus 0 divided by 2, this is going to give us 2. And when I pick m2, which is 4 minus 0 divided by 2, this is also going to give us 2. So this is the same as what we had here. So telling us that this is having the discriminant part to be 0, and this is repeated. So this one will help us to write our general solution. So as I said, always try and write the formula down before you start. So plus c2, but this one we are going to add x to it, and then we are going to have, let me write it this way, m1x, or we can just use m, right? So because they are all the same. So it means that our general solution is going to be y is equal to c1 e to the power 2x plus c2 x e to the power 2x. So this is what we are going to get as the general solution. They've given us initial condition, so we can just go through by doing that. So as I said, since this is second order, then when we get to what we need to do is we need to find y prime so that we can use the initial condition which involves y prime. Now this is constant, so I just differentiate e to the power 2x, and this is going to give me 2x, right? So this is going to give us c₂c1 e to the power 2x plus, now this is a product rule, right? So I just need to make sure that I use the product rule to solve this. So let's do that. If I have this, let me assume that this is equal to AB. So product rule, I'll let A to be x, B to be e to the power 2x. A prime is 1, B prime will be 2e to the power 2x. So product rule, I'll multiply this and then I'll multiply this. Then I'll get the product rule. So this is going to give us, so we have c2 there, so c2 in parentheses. I multiply this to this, I'm going to have 2x e to the power 2x plus, I multiply this to this, and I'm going to have e to the power 2x. So this will be the derivative. So this is very simple, like maintain x and differentiate this, and then maintain this and also differentiate this. That's the product rule here. So now that we have this, let me copy this one to the next page, and then we use the initial condition to solve that. Good. So now we have the general solution, which is this. This is the general solution. We want to find a particular solution. So they've given us y of 0 to be equal to 4, I think. Yes. So it means that we need to use this one to solve. Now we know that this implies that y is equal to 4 and x is equal to 0. So what is y? Y is 4, x is equal to 0. So I just put them here. So I'm going to have c1 e to the power 0 plus c2 0 times e to the power 0. And 4 is equal to c1 because this will be going to 0 and c1 will be equal to 4. Now we need to use the next initial condition, which is y prime of 0 is equal to 5, I think. Yes. So this implies that y prime is equal to 5 and x is also equal to 0. So now we use this because this is the one that involves the y prime. So we are going to have 5 is equal to 2c1 e to the power 0 plus c2 in parentheses 2 times 0 e to the power 0 plus e to the power 0. Good. So I was just doing substitution here. So let's see what we are going to get at the end of the day. This is going to give us 5 is equal to 2c1 plus c2. This will be 0 plus 1. And 5 is equal to 2c1 plus c2. Now we know that c1 is equal to 4. So let's just plug it in and see what will happen. So 5 is equal to 2 times 4 plus c2. And this will be 5, 8 plus c2. c2 is equal to 5 minus 8. And this is equal to minus 3. So now we've gotten c1 and c2. So now we can rewrite the general solution as what? A particular solution. So the particular solution now is going to be y equals, so we are writing the same thing here, then we do substitution for the constant. So 4 e to the power 2x, and then what is c2? c2 is minus 3. So minus 3x e to the power 2x. So it's kind of very simple with second order homogeneous equation. Let's take another one and then let's see. So same thing again. Now we want to do it. We have another initial condition too as well. So start by saying that y is equal to e to the power mx. Y prime is equal to this. And when you solve this, like for 5, 3, 4 questions, you will see that this that I'm writing here will just be off head, and you will just be writing them down, and you will just be doing the substitution straight. For example, when the question is objectives, You don't need to be writing all this. It's a waste of time unless if the question is section B. So this is going to give us m squared e to the power mx minus 2 times m ex mx then plus e mx is equal to 0. So same process again. Factor this out. M squared minus 2m plus 1 is equal to 0. Same thing again. This is not equal to 0, as we said. So our characteristics polynomial will be m squared minus 2m plus 1, and then the characteristics equation will be m squared minus 2m plus 1 equals 0. We use the characteristics equation to find the root. So here again, we can decide to use the idea of quadratic, or if you are not good with the quadratic, and do simplification. So let me use quadratic. So quadratic, this is kind of my a is 1, and then my b is minus 2, and my c is 1. So my m will be equal to minus 2 plus or minus square root of minus 2 squared plus 4, no, minus 4, 1 times 1. Good. So this is going to be divided by this, and this is going to give us 2 plus or minus, this is 4 minus 4 divided by 2, and this is going to give us 2 plus or minus 0 divided by 2, and this is going to give us 1, right? So this is going to be given as something like 2 plus 0 divided by 2, and 2 minus 0 divided by 2, and this is 2, and this one 2 is 2, right? Sorry, this one is 1, and this one 2 is 1. So we are getting m1 to be the same as m2, which is equal to 1, because we are dealing with when this root is equal to 0, as we can see from here. So now let's write the general solution down. Y is equal to c1 e to the power mx plus c2, let me say x e to the power mx. You can just use m or m2, m3. It's just the same thing because this one is double and they are all the same. So this is going to give us, this implies that y is equal to c1 e to the power x plus c2x e to the power x. So this is the general solution. We have initial condition, so let's try and find the particular solution. So we have the general solution. Let's try and find the particular solution. So let's do that. So what's the general solution? Let me just watch and write it here. So we have y to be equal to c1 e to the power x plus c2x e to the power x. Is that right? Good. So for us to go through, we need to find y prime. So I differentiate this, and I'm going to have c1 ex, the same thing again, plus I want to differentiate this. C is constant, so I maintain it out. Use the product rule for this. So this is going to give us e to the power x. That is when I differentiate x and maintain this. Plus, now I maintain x and differentiate this, and I get the same thing again. Good. Now initial condition, y of 0 is equal to 2. So we use this on the general solution. So x is 0, y is equal to 2, and I'm going to get something like 2c1 e to the power 0 plus c2 0 e to the power 0. So if you have noticed, you see that because this one is multiplied by minus, is always, kind of, it helps us to get c1 straight away, because since this one is multiplied by x, if this one x is 0, it helps us to get the c1 straight. So we have, when I finish, I'll give you one to try, and then this is going to give us c1 to be 2. Then y prime is equal to 6. So we have the y prime of 0 to be equal to 6. x is 0, y prime is equal to 6. So let's plug it inside this again. So we are going to have 6 is equal to c1 e to the power 0 plus c2 e to the power 0 plus 0 times e to the power 0. So we are going to have 6 is equal to c1 plus c2, 1 plus 0, and then 6 is equal to c1 plus c2. c1 is equal to 2, so 6 is equal to 2 plus c2, and then we know that c2 will be equal to 6 minus 2, which is equal to 4. So this one will help us to write the particular solution. So let me write the particular solution here from the general solution. So c1 is 2, so 2 e to the power x, and then c2 is 4, so plus 4x e to the power x. So that's what you are going to get. Now, one trick that I think I didn't tell you when I started this. Now, when I differentiate this, you remember how we verified that if this is a solution to a particular question, right? So this is basically a solution to this general solution here. So you can see that for you to confirm, you can basically try and differentiate this here and plug it inside and see if we're going to get 0. So let me verify that one before we do the last question, and I'll give you. So we saw that y is equal to e to the power x, I think 2 e to the power x plus 4x e to the power x. So that's what we had. Now, when I differentiate this first time and second time and I plug it inside this, I should be getting 0 because this is a solution. So I'll just go through quick. So y is equal to, I'll just factor e to the power x out and have this. So this is going to give us y prime will be ex2 plus this plus when I differentiate this, I'm going to have 4ex. So that's what I'm going to get for first derivative. Second derivative, I'm going to have something like the same thing again, ex2 plus 4x plus 4ex plus, then I differentiate this and I get the same thing again. So this is going to give me 2ex plus 4xex plus, this is going to give us 8ex. So when I add, this one is going to give us 10ex plus 4ex. So that will be y prime. Let me try and simplify y prime. Let me try and simplify this. This is 2e x plus 4xex plus 4ex. So this is 6ex plus 4xex. So I'm going to plug this, and this inside this, and I should be getting 0. So let's see if it is true. So what is y prime prime? We had 10 e to the power x plus 4x e to the power x minus 2 times y prime is 6 e to the power x plus 4 x e to the power x plus, what is y? Y is 2ex plus 4x ex. So I just have y here, y prime here, and y prime prime also here. So let's see if this is going to be giving us 0 as it is here. So this is 10 e to the power. So this guy and this guy is going to give us like 12 e to the power x. And then this guy and this guy is going to give us, okay, let me use different color here. This guy and this guy is going to give us plus 8x e to the power x. I'm going to expand this. This is minus 12 e to the power x minus 8x e to the power x. And we can see that this guy will cancel this guy, and this guy too will cancel this guy, which is going to give us 0. So anytime it is a solution, then when I come back and come and do something like this, I should be getting it to be equal to 0. So this is kind of like if we are writing section B and you have time, you can try and verify, because maybe you've done some mistake somewhere and you want to verify if that's true. Now let's do this last question. I'll give you a question to try. This one is the same approach. Pick y, which is equal to e to the power mx, y prime mx, y prime prime equals m squared mx. So let's do it fast. So 4 m squared e to the power mx plus 12 m e to the power mx plus 9 e to the power mx is equal to 0. So what are we doing here? Factor this out. 4m squared plus 12m plus 9 is equal to 0. Set this not to equal to 0 and set p of m to be equal to 4m squared plus 12m plus 9 to be the characteristic polynomial. Now from there we can set this guy here to be equal to 0 to have the characteristics equation, and we can find the root. So I love using quadratic, so let's go to the quadratic again. A is 4, b is 12, and c is 9. So m will be equal to minus 12 plus or minus square root of 12 squared minus 4 times 9. I'm not using calculator. So this is going to give us minus 12 plus or minus 12 squared is 144 minus 4 times 4 is 16. We multiply this one and see. This is going to be 54. So I can have 4 here, 5, 9 plus this is going to give us something like 144. Okay, 144 again. So this is going to give us 2 times 4 is 8. And indeed, this is going to be 0. So we are going to have minus 12 plus or minus 0 divided by 8. And guess what? This is minus 12, or let me say m1 is equal to minus 12 plus 0 divided by 8. And this is minus 12 divided by 8. 2 goes to, or let me say 4 goes here, 3, and goes here, 2. Good. Then another one is the same thing. M2 is minus 12 minus 0 divided by 8, which is minus 12 divided by 8, and this is the same thing. So we are getting the same thing. So my general solution, c1 e to the power m1x plus c2x e to the power m1x is now going to give us c1, they are the same, so minus 3 over 2x plus c2x minus 3 over 2x. So if you have mastered this, you can see that the process is not difficult. All you need to do is like find this when you get this one, and then you just do direct substitution from this. You factor e to the power m to the power x out. You set it not to be equal to 0. You find your characteristics polynomial. Then you can use the quadratic formula to generate your roots, and then you get your general solution. And if they've given you initial condition, then you can use the initial condition to move from general solution to particular solution. So try this and leave your final results in the comment section. In the next video, we are going to talk about the one that we have b squared minus 4ac, which is less than 0. So we are going to have it in the form of complex. So that's what we are going to talk about. See you in the next video.